Check out the hook while my DJ revolves it. Ice, ice, baby.
Welcome back to BT. Now, the Manitoba Museum has a cool new experiment in their Explore Science Zone. It's all about the science of cold, and here with what you can expect is Kevin Mogk joining us from the Manitoba Museum. So we're going to learn and have some fun and make a mess at the same time, which is a big part of what the museum does.
Exactly. We like to have a good time with science and make a little bit of mess all at the same time.
All right, let's make a mess.
All right, so what we're going to do first thing today is we're going to make a little bit of glacier goo to help us understand how glaciers move.
Okay.
Yeah. So I'm going to need your help here.
Sure.
We're going to start things off. I'll get you to grab the glue water solution there in our beautiful ketchup bottle.
Oh, that's very nice.
It's one of the few things you should not do in science is mislabel your bottles, but this one's okay. If you eat the glue, it's not going to hurt you. So.
No.
So we'll put in 2 tablespoons of the glue here.
There's 1, 2. Okay.
There we go. Perfect. And we'll just toss that over there. And now we're going to add, color things up. We're all about glaciers, so we're going to go a nice ice blue. So we'll put a drop of
just
that
one
in there. Just one. Beautiful.
Oh, that's 2, sorry.
Well, I'll forgive you.
Okay.
And now grab that stir stick, give the whole thing a good stir.
Now you're going to surprise a lot of people when you tell them that glaciers move.
Yes.
But they do.
They do. They can move glacially slow, as you probably understand. They'll go anywhere from 900 to 800 meters a year.
Ooh, that's not fast.
That's not fast. But on the flip side of that, some of the fastest glaciers have gone about 76 meters a day.
Oh my.
Yeah.
Okay, so how do you travel at 76 meters a day when you're a giant frozen block of ice?
Well, you're going to be sitting on a nice cushion of water. So if you have a cushion of water, just like skating, it gets you going a little bit faster and you move real fast.
Okay.
All right, now to finish up our glacier goo, we're going to need our borax and water solution just over there. That's the stuff.
Yep.
So we'll get 2 teaspoons of that in here.
Okay. Borax and water, and if you're making it at home, 2, good.
There we go. And
another
again, stir that all up. It's going to get nice and gooey. And we're going to have ourselves our very own glacier goo.
Wow, did it ever?
Yeah.
All right.
Now here comes the fun part. I'll get you to make a cup with your hands.
Thank you.
Just pop that in there. And what you're going to do is you're going to want to roll that into sort of a bit of a ball.
Okay.
And there you go. You've got your glacier. Now,
that's our glacier.
I went ahead and made us some larger glaciers to play with today.
Okay,
so
good.
we've got 2 over here.
Purple and...
I'll grab one. You can grab the
Sure.
other. And we're going to pop these onto our slopes. So just peel that out of there again. We're going to make a nice little ball.
And this is why you don't do this at home, kids. You do this at the Manitoba Museum.
Oh, yeah. Good
So now-
mess. We've got paper towel to clean the kids up. So anyway, just pop that at the top. Give it a little bit of a press.
Okay.
And we will see slowly, of course, that the glaciers are going to start moving downhill. Now this shows how glaciers can move over different terrains. We've got 2 slopes,
okay,
and we'll come back in a second to see which has moved further, so faster, of course.
Okay, okay, so our glaciers are moving.
They're moving ever so slowly, but I've got a little bit of a challenge for you today.
Okay.
I'm going to get you to pick up an ice cube without touching it with your hands. Ooh. So I'll get you to reach into the cooler over there, pull out an ice cube.
Okay.
Oops. And I'm not going to make it easy for you. I put some water in here, so it's going to slide around as well. And the only thing I'm going to give you is, of course, the materials here on the table. A nice piece of string, there you are, and a little bit of salt. So you can give that a try.
Okay, so the salt has to be, I don't know, like this. No, that won't work. And I'll do tie a knot, and when can I give up?
Whenever you want.
Because this is going to be really...
Really?
Yeah.
See,
yeah.
Yeah,
okay,
no.
Help me out.
All right, so what you're going to do is you're going to wet the string a little bit with the water. So we're going to get some fresh water on the string. That's going to help us out. You're just going to lie that across a section of the ice cube, just like that. Beautiful. Oh.
There you go. Okay.
Now open up the salt, and you're going to dump that.
Thank you.
A little bit just over the string onto the ice. Now the nice thing about salt, as some of you may know, it lowers the melting point of water.
Okay.
So instead of freezing at 0, as we add salt, it starts moving slowly towards the -2 range.
Oh, okay.
Yeah. But to do that, you still need to pull energy from the environment around you. You can't just melt without pulling a little bit of heat from somewhere. So what's actually happening is we're pulling heat from the air and even the string that is a hotter water. And so that water on the string is now freezing, because it doesn't have any salt in it, to the ice cubes. If you pull up gently, just like that, you've got yourself an ice cube on a string.
The science of cold. Coming up, we're gonna do a little bit more. We're gonna make things a little colder than -2. How cold are we going with the liquid nitrogen?
We're going 196 below 0.
We are on our way to 196 below 0 Celsius with the Manitoba Museum. We got that and more coming up on BT. How's my glacier doing?
I'm doing great.